Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3 and we will be presenting about mini project ECG353. Our group consists of 4 members which are Muhammad Kazif Fahmi, Muhammad Yusri Afiq, Fifi Ashkin and Cik Nurul Suhaila. So in this project, students are required to identify the subsurface investigation works that are commonly carried out for the proposed construction works. Next, students need to analyze the soil profile of the proposed construction works based on borehole profile and evaluate the different stresses in soil due to different surface load. So this is the introduction for this project. Borehole soil investigation is a method where long and narrow holes drilled using a number of specialized procedures are used to research soil and rocks in the Earth's subsurface. Boreholes can be built for a variety of reasons, including the extraction of water and other liquids. To acquire sample for visual inspection or laboratory testing, rotary wash boring method are used. Wash boring method is a method of progressing boreholes in most type of soil for site exploration and geotechnical inquiry.
The apparatus that we use to construct the model of borehole are soil, water bottle, paper, watercolor, scissor, and glue. This is our model. For borehole 1, first layer is silty clay, second layer is clay, third layer is silty clay, next layer is clay, and last layer is silty clay. For borehole 2, first layer is silty clay, second layer is clay, third layer is silty clay, next clay, and last silty sand. So basically, the borehole water come from rain and river leak through layer of rock from the underground area. Water layer of rock or clay separate and restrict underground water bodies at different depth in different areas. These areas are called aquifers. A rock aquifer can have their aquifer yield boosted by natural cracking. Groundwater is stored and transported in solid and naturally occurring breakage within the rock. Boreholes are drilled into a network of cracks that yield water.
The first soil profile is due to the total stress. The radius for water tank is 10 meter and the length and the distance between water tank to borehole 1 is 6 meter and the distance between water tank to borehole 2 is 8 meter. So from the soil profile, the yellowish brown color is type of clay and the red brownish is the type of silty clay. So we can know the different type of soil based on the color, which is 1.5 meter until 3 meter is clay, and then 3 meter until 4 meter is silty clay, and then 4 meter until 4.95 meter is clay, and 4.95 meter until 9 meter is silty clay, and then 9 meter until 10 meter is clay for borehole 1, and then for borehole 2, 1.5 meter until 10 meter is silty clay. So the bold line is the total stress due to the total stress. The bold line is due to total stress from both borehole. Okay, so this is the second soil profile, which is due to vertical stress due to weight of water tank. So the soil profile, the depth and the color is the same from the previous one. The difference is the bold line.
for vertical stress due to weight of water tank. So I'm going to present about vertical stress distribution. Vertical stress distribution in soil happen when soil lying above the point and by any structural member or any type of loads placed on that soil mass. Vertical stress is one of the main stresses that confine underground formations and have to deal with. Total stress analysis is the stress carried out by the soil particle and pour water in the soil void. It is a short-term task to see if the soil sample is stable before it evaporates. The principle of effective stress is the total compressive stress that is applied normal to a specific object. So this is the formula for to calculate the effective stresses. Vertical stress distribution in soil can be determined through the surface load, or it can also be determined from overburden pressure. By using Boussinesq's equation, we can determine the value of vertical stress from formula. Vertical stress equal to applied stress, which is 100 kilopascal, multiplied by influence factor. So this table shows that how we calculate the vertical stress due to weight of water tank, which is first we need to assume the value of R and A in meter. This the value R is constant value is 6 meter and the A for borehole 1 is 10 meter. And then we need to calculate the Z over A and R over A. So from that we can determine the value of A and B from table influence factor for vertical stress due to uniformly loaded. And then if this calculation also includes the interpolation method to calculate the value of A and B. So after that, after we get the sum of A and B, we can calculate the vertical stress due to weight of water tank using the formula applied stress multiplied by sum of A and B. So for table 2 shows that how we calculate the total stress. First, we need to identify what type of soil at certain depth until 10-meter depth of borehole based on borehole log form. So then we need to determine the density for based on the type of soil, which is for clay 1330 kilogram per meter cube, and then for silty clay is 1260 kilogram meter cube. So after that we need so after that we can calculate the vertical stress due to weight of soil, which is just multiply the density and the depth value, then convert the value to kilonewton per meter square. So from that, we can calculate the total stress by sum up the value for vertical stress due to weight of soil and the vertical stress due to weight of water tank at certain depth, which is 1.5 meter, 1.95 meter, 3 meter until 10 meter depth. So this is the table for how we calculate the vertical stress due to weight of water tank for borehole 2. The calculation, the formula is all the same. We use the interpolation method and calculate the vertical stress using the formula. The second table for borehole 2 is to determine the value of total stress at certain depth until 10 meter. So the calculation and the formula is the same as the previous table. We use the same method.
So, in a conclusion, our group can conclude that we need to build the piling system before constructing the water tank because the value of total stress that we get from the data are higher than the value of shear strength. The benefit or the advantage just of pile foundation are the pile can be pre-made its length, its width and size based on site needs. It's also possible to put it in a very massive area and install it in a very lengthy length. The piles can be used in areas where drilling and holes are prohibited, and the piles is quite nice and clean. So that's all from our group. Thank you so much.